I was in the IT field for almost 20 years before I decided to quit. And for the last 7 or 8 years, I have been in the field of science communication, and that is my full-time job. And of course, tinkering is my passion, and I work with high schools, students and teachers to take various concepts to the physical level, and that is what I would like to share in this presentation. So these are some of pictures from some of the workshops I have been taking. Mainly it started with physics, high school physics, how difficult concepts can be realized or visualized by the students in the classroom. And then I moved to another area called mechanical toys, where students bring their ideas to life with the help of everyday things. And this is where I got switched into astronomy. I will shortly share that experience. And these are the three areas which I normally interact with students and teachers. So I can say that I'm the youngest astronomer. I'm just into astronomy for the last 3 years, though astronomy is the oldest science. It all started in one of the workshops where kids they see everything around and they try to bring or make models based on their idea. And one student asked me, "Sir, can you tell me why we see the same side of the moon?" And there are a couple of questions related to astronomy. Then I told him that, yeah, I heard that something like that is there, but I don't know myself, so let me go back to drawing board and find out. And then I thought, instead of making a cardboard model, can I just make it more accurate so that I can test various things like Adhik Mas, lunar months, solar months, and have a correlation between physical model and actual measurements in terms of calibration. So that is where I started building astronomy models per se in year 2023. And this is the first model I built, which covered most of the concepts in high school geography, I will say. 6, 7, 8, they have concepts like rotation, revolution, eclipses, seasons. Everything was addressed with the help of this just one model. It was published in 23, and so far it has got 1.2 million views, most popular. Many students, teachers are using in their curriculum as a part of this. And I thought, since I made it and I got request, so that they also wanted this model, and that is how it started my journey. And right now I have built around 20 models or so, 20 plus models. This is a channel I have, and there is a special playlist called Bharatiya Khagol Shastra, which I normally consider this is one area which is very special to us. It is not something which can be addressed in the Western world. So I decided to take concept, work on it, build models, and that is how I try to visualize the idea and understand the concept. So as far as high school and education goes, Sun, Earth, Moon and inner planets are the two models which I normally use in demonstrations. But there are other models also which are very important. Tithi, Nakshatra, we use it in everyday life. Precession of equinoxes is another term which is quite often used in our discussions. So these are used for higher standards. Many Vedic schools are using these models to teach their students how Tithi changes, what Tithi is, what Nakshatra is. And these models are meant for higher grades or standards. Now I will come to my work as such in terms of workshops and interactions I do with local schools. And I'm planning to share videos just to give you a feel and why I'm doing those activities. So mostly my belief is that instead of giving lectures and showing diagrams, if students, they build the model themselves, they can understand it better. And that is where all the interdisciplinary work they have been doing in terms of maths, in the area of physics, they get to apply it actually. So let me play video in the next slide. I will try to cover these areas and show videos which I have taken as activities. So these are the states and areas I have visited so far, covering almost from Leh Ladakh to Andaman Nicobar, even in Northeast. And I work mostly in the rural area. I work with local schools and Jilla Parishad schools. Yeah. So just like previous speaker said, I also insist on using local material. Here, students are trying to decide directions, based on everyday things. Idea is that not just one model is there doing demonstration. Everybody is involved. Everybody makes a model and test it, in the field. So they apply their local logic. This is where they are making a sextant, where they will find the altitude of the sun, as well as this, they can use it in the night to aim at the pole star and find their latitude as well. They also use geometrical constructions to build a sundial. This is one of the many variations I have introduced in the field. There are many ways to make the same sundial, and this is how you can make sundial out of the box. So this is another school, and this is another variation of the sundial. They have just used card sheet, but the focus is more on doing things, planning to leverage the knowledge they have learned in terms of geometry. Okay, these are the models which I have built, and I also take these models with them so that I can understand difficult to understand concept. Let me, sorry. The previous model was really, previous activity was about the faces of the moon, where actually you can hold a ball and take it around and experience the faces of the moon. I also wanted to leverage other areas as far as astronomy is concerned. So problem statement was that can we learn gear ratios using simple astronomy concepts. So students were given a lot of gears, and they were asked to try various combinations, like can you configure the dial to experience various seasons, how axis of the earth keeps its rotation with respect to the sun. So by using various gear ratios, they will calculate the movement, they will calculate the number of rotations, and they will measure the gear ratios. So this is just another way to introduce astronomy and then marry with other concepts in terms of what they learn. So worksheets are a great way to guide the investigation. So I always ensure that for all the activities, worksheets are given. This is the Dodges, when I was in Dark Sky Reserve, I also conducted activities for the local school, where 1 hour session is for interaction with students to convey the same concepts. This is a school in Leh. So models are kept for students to interact with, and they investigate, they try to understand how things work, they play around with it. And mostly interaction happens in a small group, so that I can interact with them, they will ask me questions, and then that is how it works. So this is a model which shows actually why eclipse doesn't happen on all full moons and no moons. The same model is also available in the demo area, which I have got. Okay, I will move to the next slides. Okay, I always try to integrate not just astronomy but other topics also into the activity, so that some part from mathematics, physics, and the more focus on process skills. It's not just astronomy or content, but I am interested in building process skills as a part of interaction. So are they able to collect data, are they able to draw it, are they able to interpret the data and draw some graphs and take it forward. So that is something which cannot happen in a day, but I think I have initiated the process, and that is something I plan to continue moving forward. Some learnings from these workshops. Always use worksheet as activity guide. It helps, in a planned way. Many students during interaction, even teachers, are not aware the position of full moon and new moon when it comes to interaction, the placement of, sun, earth, and moon. Everybody knows sequence of planets from the solar system because it is there in syllabus. But when it comes to finding the number of days based on observed revolutions of each planet, they are finding hard time. So maths multiplication is everybody knows, but when it comes to application, it is very difficult to implement it. That's what my finding is. Many people say that syllabus में नहीं है, ये नहीं है, but then I think if given a path and areas in the syllabus, teachers understand it very well. So I have listed, when I interact with teachers, I tell them that for this standard, these are the topics you have, and it is where models and activities will help you in the classroom. Similarly, for NCERT, recently I took a session for Delhi Public School, and NCERT has a new syllabus for each grade. I have listed 25 areas where astronomical concepts are directly linked in the classroom. Okay, so I think my last slide. These are the steps which I want to do, but the last point is very important. Work with communicators like you. I would like to collaborate and work with you and understand how we can take this forward. I will end the session by these small lines. These are, composed by my son. Gazing the amazing endless sky, full of stars and spheres, aiming to solve the curious why, learn with globes and gears. Thank you very much. For online. Sure, thank you very much. I would love to interact with you. In fact, as a part of my, this year I was planning to visit Srinagar and, nearby areas, but due to floods, train got cancelled and I could not visit your area. But definitely I would like to, work with you on this.
So now let us thank.
Thank you.
Really good morning, and let's go to the next speaker.
Hello. Okay. So, hello everyone. Myself Rupesh Labde, and I'm working currently in IUCAD Science Popularization Department, and which is also known as a SciPop. From the last 2 years, we have working on this project, and it is also shared with the public. That is Velo Ganeshwari, and it's the name of the bicycle, but you can see here it's looking different one. And so we are trying to explore some different topics in science and astronomy with it. So this is what the actual picture. So you can see here, because I just titled the Velu Ganeshwari, not written there bicycle, so you should understand it's the name of a bicycle. And Velo is some of the first names that is given in Latin to the bicycle, which is known as a velocipede, its actual name, but it's known as a pedal power machine, and later on we called it as a bicycle. And we know that many scientists, this was the favorite instrument and the favorite companion for the traveling. And you can see here not only the science in the bicycle, but we can explore more different concepts in science and physics and also astronomy with the bicycle. So you can see here lots of experiment, and we counted it as near about 40 experiment which is attached to this, and all they are working experiments. So students can go with it outside and they can explore. So this was the main concept, and we use it as a not for generating any electricity or anything, but as a good teaching aid for students and teachers also. So we also know that bicycle itself has a big history. So it's not a device that we are knowing nowadays, but it is having a transformations from the last many years, that is from the 1887, and these are the shapes of the bicycle that is continuously changing, but we know that this shape is not changing yet, and nowadays there are modern bicycles that accordingly our what we say the expectation we are changing it, but we know that our science and space journey also started with it. You know these pictures very well, and that's why we also put the rocket one there. Then we also know that how it helps to for a learning purpose for everyone, not only as students, but peoples when they see the bicycle, they get immediately they get catch. As before my session, I would just want to show the pictures only, but chair also wants to bring the bicycle here. So that's what this concept gets attracted everywhere. So we know that our current, the previous classroom teaching was mostly related with books and boards, and we all the educators here try to changing that, and our new NAP concepts is also based on that. So we are trying to get more experimentation. As myself journey also start with the experiments. One single experiment changed my life. So I think that why not we start with our schooling days. So the best friend during schooling, that is mostly the rural students use, I think more than 70% students use the bicycle for their regular traveling, and they didn't know that their single bicycle without any attachment to it also contains big science. Okay, so I found some research paper and PhD thesis which is only on the wheels of the bicycle. Okay, so I found this instrument very interesting, and that's why I started working on it. And then we have some attachment and some of the experiments that can be teach very well with this, like Newton's color disk. Then if we attach the Android phone to it, we can again add more than 25 experiments to it. Then we can see there are different kinds of aspects that we can focus on. That each instrument nobody needs to purchase, already many people have it. Okay. Then the concept is anywhere methodology, that is you can take it any on playground, in public gardens, on the streets, in daytime and night time. And so we added some experiments here like that. We also have here a telescope, then there is a microscope inside the bus. So we can say that from telescope to microscope you can explore everything. When the students go outside using a bicycle, they can explore that things too. There is solar cap, there is a dynamo, which can we say that it is a mechanical power generator. Then there is a solar one, the solar power generation, wind power generation you can explore. Then with the help of this air pump, you can blow that rocket, and then if you add water into that, then it again takes more height, so that they can explore more through that, different principles of air pressure and water pressure also. So these are the list of the experiments that can be do alone, and with the some Android applications you can explore more. So these are like the main principle which is working in the bicycle, that is gyroscopic thing, then centrifugal force, then projectile motion, gear mechanism, as sir already talked about the gear ratio, when they can start with this bicycle. Okay, so then hydraulic stand, we are trying to move that stand with the hydraulic. Okay, then the bicycle geometry itself has many advantages, and we kept some small experiment to demonstrate all this inside that box also that comes with bicycle. Then There are, you can see here the experiments like a CD spectroscope, pinhole projection, Newton color disk, then optical illusions, then convex and concave mirrors we kept there at the handle. So you can produce a ray diagram by using lasers. So lasers also kept in the box side. So you can produce a ray diagram and tell them why convex mirrors are used on the bikes and cars. Okay. And then with this, as students are going outside, why they can't explore the sun also. So solar goggles are there. Then the energy and nature principle, that's why windmill generation, pedal power generation, then solar power lamp. We kept stethoscope also there, but the stethoscope that is we made, not doctor's one. So that we can check heartbeats before driving a bicycle and after driving a bicycle. Then the gas law, when we pump the air into the tube, then there is some heat generation. So we can explain through that, and the bottle rocket one. And there are many more. But with this, we are also going outside. Why can't we explore the motion of the sun with a star dial, sun dial, then constellations map are also there. Umbrella constellation is there. Then astronomical laser and the solar motion, some exhibit inside this box. So this was our start. Before 2 years, we inaugurated this bicycle in Pimpri-Chinchwad's some of the schools, and they find it is a very good concept to learn. And then in the G20 exhibition, everyone pays attention to it, and they take information from us. So this was the visit by many dignitaries during the exhibition. And this is, I think, the most important picture. So this is just 1 year back in Delhi. And also this video is, I think, is this playing or not? Oh. So this is uploaded also on the Minister of Education Twitter handle. So these are the closer look. So the exhibits with the bicycles, I have just showcased some of this. The students exploring the experiments which are attached to that. And these are the kinds of experiments. If we attach some Android phone, and there are some applications, standard application. With this, if you can attach these cell phones to different parts of the bicycle, then you can measure different parameters. That is rotary speed, then the XYZ direction, the gyroscopic motion, like that. And these are some apps that is, if you use this with this, then you can explore more. So thank you so much. And this exhibit is at AC Hall, Port. If you want to get more question related to that or want to see this, we have kept there. Okay, thank you so much. Questions?
Given the fact that nowadays smartphone is there with everybody,
Yeah.
have you considered the possibility of integrating all the experiments into your own smartphone app? So if you make a Velo Ganeshwari app, then you can put all the experiments in there. You can keep on adding experiments.
Yes, yes.
You can also give information, links to YouTube videos, etc., whatever additional information you need for the students to conduct the experiments. That also can be part of the app.
Yes, yes.
Then it will become very easy for people to scale it up.
Surely we can try that.
So let's thank
Thank you.
Good morning all. I am D. Aravind Raja, headmaster from the Directorate of School Education, Puducherry. I started my career in the year 2000 as a teacher, primary school teacher. And now after 22 years, 24 years, I became the headmaster for a government school in Karaikal. During this journey, 25 years of journey, I have learned many informations regarding astronomy, that what type of activities that can be implemented in classrooms and how the students responded. These are the things I have to share. As a teacher, I have practiced many activities in my classroom for the last 24 years. That type of activities, what I have implemented, I'm going to explain it. So the main objectives of this topic is developing scientific literacy among the students and foster curiosity and creativity, and to create and to build critical thinking and problem solving skills, promoting STEM interest, encouraging students collaboration and teamwork, and make astronomy accessible to all students and public also. So these are the hands-on activities which I have started. Before starting my activities, what I experienced is, the first one is training part. We have to get some trainings before going to the students. Such sort of trainings I received from the Vigyan Prasar at the earliest stages. Here TVV sir is one of my guide during my early years, TV Venkateswaran sir and Arvind Ranade sir. I'm not forget in my life, because my astronomy journey started because of them during the year 2000. During the first 2 years, I have been trained in astronomy activities by Vigyan Prasad Government of India and other organizations. I am an executive member of Pondicherry Science Forum. Through these organizations, I started my science popularization activity. Then I went to my classroom and started exploring the astronomy by making the students to observe the natural sky first. First I made the students, as I'm a scoutmaster, I took my students to the seashore first during the early morning. We will go and reach the seashore by 4:30 a.m. From that time we observe the sky. If we go to the beach early morning, you can see the blue hour. Before the sunrise, you can witness the blue hour. That is very pleasing time. That's a very pleasure time for us. The students started to explore that thing first, blue hour. Then they started to observe the sunrise. And then we start to discuss some sun-related informations. They ask many questions. At the time, some birds are flying on the seashore. They watch it and ask many questions. Through this field visit and observation, I created interest among students in astronomy in the classrooms, in schools, as well as among the students and public throughout the Puducherry as well as in other states of India. And conducted activities such as observing and marking sunrise. Even a chalk piece is enough. Our TVV sir trained us to observe the where does the sun rise? This is the question he asked in the year 2000 towards me. At the time we say directly in the east. He just trained us, go to the upstairs and stand towards the sunrise and mark on the wall of the stairs towards the sunrise. Daily you go to the same time and mark the sunrise. You notice the movement of earth. The sun rises from northeast to southeast. You can explore it within a week using a simple chalk piece. So without expensive materials, we can explore the astronomy. So this type of activities I have implemented earlier, and then I taught the basics of photography to the students. You can use low-cost materials like ball and mirror. This is a very simple technique to observe the solar eclipse and transit of planets. Here they pasted a mirror in front of the ball and pour some sand for not moving the ball here and there, and place it in a used cellophane tape ring and placed it, and they positioned that mirror towards a wall. There's an empty wall, there is no paste. If you want a clear image, you paste a chart or paint a white wall. You can see very clearly the sun's image. You can view the transit of Venus or transit of other planets very safely using this method, ball and mirror method. We observe the sun and we observe the sunspots. We observed the transit of planets, solar eclipse. Each and every activity you can make the students to explore using this ball and mirror method. And we provided worksheets to observe the solar eclipse, transit of planets. I developed some rubrics and worksheets for the students and provided them. And here is the sundials they prepared and used it in their homes. They daily report about the sundials and discuss any other models we can prepare and compare it. Like that, the discussion and the activity goes on. I'm very much interested in photography, so using my Nikon DSLR camera, I started to explore on my own. I don't have any photography learnings or workshops. I started on my own. I go through the websites and learned some YouTube videos how to take photographs of the sun and moon, and started to photograph the super moon and the full moon and the phases of the moon regularly and show it to students. The students voluntarily came, the classes 6 to 8 students voluntarily came and make me to teach them the basics of photography. I taught them the basics of photography and they started to take photographs of the moon. Here few photographs in the next slides taken by the students, the moon and the sun, as we are going to see in the next slides. This is supermoon taken on 14/11/2016. And for public outreach, what we did is we set up a science corner in the classroom first. We have different corners in the classrooms: English corner, Tamil corner, languages corner, mathematics corner, science corner. I added one more corner in the classroom, that is astronomy corner. Whatever the activities done by the students kept inside the classroom, the other classes will come and witness that events and learn that activities. So here the students learning about the basics of photography and how to take photographs of birds, the animals, and then they started to take the photographs of the moon and the sun. This is the rubric, a small rubric I developed. The activity, for one example I have given here, that is the learning objective: understand the relative sizes and distance of planets in our solar system. Activity is students create a scale model using everyday objects. Example: clay, paper, marbles, balls, beads. You can use a very low cost material without spending more money for these activities. Name of the students: creativity and presentation, 30 marks. We have to evaluate there so that they can learn in a very interesting manner. So this is the understand the phases of the moon and how they change over time. This is the annual solar eclipse taken at Coimbatore, I think, during the year December 2019. These are the annual solar eclipse photographs. I tried to take the ring of fire, but more cloud coverage we experienced with the TV, sir, yes. So I go straightly, these are the public outreach and activities done by us. This is the blue hour the students witness daily, the sunrises and sunsets. This is the silhouette photography. The students take silhouette photographies. This is the public outreach, that is Transit of Venus 2012. More than 10,000 participants witnessed this event. And the students started to observe the sunrise with birds. This is the photograph which I took. More than very difficult to take this photograph. The swift birds shift very fast during the sunrise at that time. It takes 15 days to take this photograph. Then we connected astronomy and birds. We discussed this information among the students. This is the staircase active. Where does the sun rise? So you position the sellotape is pasted there. Daily you have to paste a sellotape to the direction of the sun. This is common new eyes. During the year 2020, during the pandemic period, I have created online program for 100 days and spread the astronomy information to the students and public. This is comet neowise, a stool model, a simple plastic stool from our home created as model comet neowise. During the year 2018, we participated in the IAU Moon Landing 50 event organized by the International Astronomical Union. The students participated and in 18 activities such as moon model making, Rangoli art competition, Moon Landing 50, a girl was drawn it, and drawings of women astronomers, women participation in astronomy was discussed among the students. 18 activities conducted, and it sent us a report to the IAU Moon Landing 50 IAU event. We received a prize among 126 countries. In India, the students of government middle school, Nolayarpet, Puducherry, received that prize among 126 countries, among 10 lakh participants. They received a telescope as well as a augmented reality model of the moon, the posters, everything. Given as prize from the Astronomical Union, the students received, and the director of school education and the officials of the education department appreciated the activities. So these are the events, they got appreciation from even small activities, what we can do as wonders in the astronomy. This is the example. We visited the planetariums, field trips, and this is published in newspapers. And 100 hours of astronomy, the students participated. More than 30 to 40 activities which I have conducted in my classroom for the last 24 years. Whenever we have time, we do this. This is the very important project we did. More than 3 months we did this sunspot, counting sunspots on an image of the sun. Using 3 methods we conducted the project. First one is sunrise photography and homemade telescope, ball and mirror method, pinhole projector. We observed the sunspots for nearly 100 days, more than 100 days, and we compared with the SOHO images, solar and heliospheric observatory, because we are not experts, we don't have expensive telescopes. So using available materials, we photographed the sunspots and compared to that sun images. We found it correct and we were amazed by our activities. And these are the rubrics. These are the activities which I have conducted so far from 2002 to till date: solar eclipse, lunar eclipse, supermoon, blue hour, sunrise and sunset, National Space Day, comet neowise, Venus at western elongation, Mercury, Saturn and Moon Planet Parade, daytime astronomy, home astronomy, 100 hours of astronomy, online quizzes, moon observation, transit of Venus 2012, These are all the activities. More than 3 lakh students and teachers participated and witnessed the events for the past 25 years. These are the learning outcomes which we have achieved during the learning astronomy. These are the challenges we have faced: limited access to astronomy resources and equipment. Even though we didn't have any expensive telescopes, we tried our level best using available materials. These are the challenges which I have faced, and these are the strengths. Hands-on activities makes astronomy more accessible and enjoyable. This already I have discussed earlier. And these are the assessment rubrics: peer review and reflective journaling. These are the assessment and evaluation techniques followed by me. And these are the future plans: developing online astronomy resources and virtual labs, collaborating with national and international astronomy organizations for global projects, and other STEM subjects for interdisciplinary learning. So this is the conclusion: engaging students with astronomy through hands-on activities and science projects makes learning fun and interactive, sparking curiosity and creativity. By exploring the universe through experiments and projects, students develop a deeper understanding of astronomical concepts and a lifelong passion for science. Thank you.
Sorry, but we don't have time for questions and answers. So let's thank him and
Thank you.
Hello? Yeah. It's on the right here. Priya, yeah. Thank you. Okay. Yeah. So it's after all these 3 talks, which was so good and such fun with such activities, I'm worried that my talk would be kind of boring, because the problem I'm talking about, I'll be talking about this magazine or newsletter called Chekomukhi. Okay, it basically means a bright star, a bright stone, whatever. And this is about my work with Chekomukhi. I've been writing for the past 5 years, and let's talk about my experience about it. So there's no fun activities. That's what makes it slightly this thing. Okay, so Chekomukhi is basically, it's a flagship science popularization program. This is run by Jana Vigyan Vedika. This is a people science forum in, I've been working with the group basically in Telangana and Andhra Pradesh, and they basically run this thing. So it's a magazine which comes out every month, and it basically goes out, it's published since 1990, almost 35 years, rather exactly 35 years. It's actually in Telugu. It's basically, its content, it aims to promote scientific temper, rational thinking, technological awareness among students. And the good thing, what attracted me towards it was the fact that this basically Janavigyan Vedika, they are most active in rural areas, not in urban areas. I mean, urban also it's there, Hyderabad, but obviously in urban areas, children, most of them are stuck to their smartphones or all kinds of fancy devices, and they probably do not even, if they do get the newsletter. This is published, about 6,000 copies which are published every month, and it's distributed all over the state. Okay, and but I always assume when I'm writing it that it's more for these rural kids, because I think they are the ones which will actually open it and read it, because our city kids have become so mechanical in the way they deal with things. It's that, even just as an anecdote, in the university where I work, this is Maulana Azad University in Hyderabad, it's a central university, and a lot of our students are first generation learners. And what I've noticed is that these students are so good, any problem in the physics lab, you say this thing has to be fixed up, immediately the guy climbs up and he starts fixing things, because they are used to doing such things. But our urban kids, I think if the fuse goes out in their house, they don't even know how to fix it. But these ones who are from smaller places, they generally fix their stuff. They know how to do it. Okay. So when this thing was proposed to me in sometime in the first episode I got out was in April 2021. I told them obviously that I don't speak Telugu, I don't know Telugu. So they said, it's okay, you write it in English, the children will learn English also, there's no problem. So then when I was trying to plan what to do, I basically thought of two components. One which was called Astro Bits, which would have Astro News and info. And then an AstroCon, where basically it's on explaining astronomy concepts to students. And I also added something called AMA, which was Ask Me Anything, which I gave them my WhatsApp number, and regularly these kids write to me on WhatsApp asking me some questions, some of them all kinds of questions, and probably because it's faceless, they are not even nervous about asking their questions. So it works out quite well. And now since there's stuff on YouTube, they even ask that, then I put the answer on YouTube as they wish. I also added another component called AstroQuest because we've been active with astronomy Olympiads. So what I do is try to put Olympiad kind of questions so that kids can, think, depending on whatever the caliber of the child is. For example, you could have a question, what would be the duration of a lunar month if the distance to the moon were 4 times the present one? Can such an orbit be possible? Or, various questions which are Olympiad types is also what I add. So this was the first one which I wrote, which actually was on request. They actually told me to do it on Rakesh Sharma. That's why I did it. It's not commemorating any special day. So this is the first one which I wrote in April 2021, where you had stuff about Rakesh Sharma and stuff like that. Obviously, after all the lovely stuff that we saw in the last 3 things, this is basically text. But finally, when it comes to learning, text also plays an important role. So I had that. For example, there's one, women in science. So they give me a lot of freedom in the sense, whatever topic I want to add on, depending upon whatever's the hot topic for the season, whether there's an eclipse or there's Chandrayaan launches or whether there's a comet which is to be observed or whatever. They've actually almost kept it. Once in a while, they do request me that please write it on some topic which they want. But otherwise, most of the time, I do have quite a free hand that if I think something is an important thing to be spoken about or whatever, then that's possible. And so you can actually do it on whatever you want. So I even added some more things, like, for example, adding them some activities. For example, Mobius strip, tell them what's a Mobius strip. You can make a Mobius strip very simply and tell them the advantages of it. So I even added a few of these things of the activities. The only problem in this is that I do not see the children while they are doing it. I just put it. I don't know how much of it works out, what is the thing. Though as part of Chekomukhi, then they regularly have quizzes and some other events. But then that's a different set of children who come. You don't exactly match them with the ones who are reading the newsletter. Yeah. Now, along with that, I also do a lot of writing in resonance on various topics, on various things. Now, resonance is a slightly higher level where you have college types, students, undergrads, but they read it where you do semi-technical kind of stuff. And so then that got me to the question about what happens with printed media. For example, this printed newsletter, when you write it, it obviously works very well in the sense that, it's tangible, it's permanent. There's no technological barrier with the Chekomukhi thing because wherever, the newsletter goes, kids can read it and, there are no issues about, power or internet or anything. We have done workshops in districts in Telangana where literally it was a government degree college. Every room had a projector, but that district there was no power all through the working day. Simple. Power only came in the evening because it was considered that is the time when they need power because they need to switch on their lights. But in the day, there was absolutely no power. This is very close to Warangal. And thanks to funds, they had everything in the classrooms, like projectors, computers, everything. But how do they run it? There was no way to run it. This is like 8 years ago, 8 years. Yeah. This is called Jammikunta, the place. It's near Warangal. But yeah. And a lot of, I don't know how it is in Maharashtra, but specifically in Hyderabad, even 60 kilometers from the city, where people have farmhouses and all that, often during the day, there's no power. The power is only switched on in the night, which is really absurd, but that's how it is. Anyway, so you have this advantage with this printed newsletter because finally it can go. There's the advantages, but obviously disadvantages. We have to move with times. This one has static content. There's high production distribution cost. There's limited interactivity. Various issues which we have this print in this thing. So then I came up with this thing that in case some of these students do have availability of internet as well as smartphones and things like that, then what can you do? So we have a YouTube channel which we started sometime in COVID. That's when everybody opened their eyes to the online world. And then what I did is I put some of this stuff onto, what I started doing is every newsletter, I also started uploading a video on it. If the student finds it difficult to read text, he can watch a video, which was put up on the channel. And so for example, there's an Astrobits and there's, it's all there on the YouTube thing. So what happens is, here's Yogesh's latest, this thing. So this was, I think, the January, I don't remember, the Jan or the December episode, where I give them the QR code for the video, so the students can read it, and then the ones who have access to the internet, they can actually use this and see the YouTube video. So both things come with that. And then I thought I should go even more, so now I started a Spotify podcast itself, which has the same thing. This is for the people who do not get Chekhumuki, so they can then directly see the same videos on the Spotify podcast and get back like that. So I would end with my conclusions that the print media, we already spoke about the pros and cons. Digital media, obviously the advantage it has, global access, interactive, full-time data. But obviously you rely on devices like internet, etc., which is not exactly available everywhere. We believe that, it's not exactly available. So I would conclude with, that still traditional media does have its relevance in two different places that educate Oh, it fell. Wow. Okay, so in conclusion, I would say that the print media still plays an important role even in today's world, but they serve different purposes, and I think a good idea is to integrate both of them, use both. We cannot reject one, but obviously in today's times where outreach has now evolved from print to digital to podcasts, people find it very easy to watch podcasts, shorts, things like that, and now we have Gen AI, so I even work in the university with our distance program, okay, the distance education program. And now what we are doing in our university is we are using our self-learning material, using AI to generate videos of our self-learning material in smaller bits, which we think will be even more helpful for people to study, because it's creating these short videos, and AI generates it in a jiffy, right? You give them the whole material and you say, make me 15 videos, one per chapter, and it makes it like that. So probably, outreach thing would actually evolve more into that, where, ChatGPT, you say, okay, tell me about, the Atlas 3i, this thing, and it'll just create you tell it, create me a video and an article on it, and that's it. Then, what would we be doing? So probably things will evolve like that. But let's see how it progresses, and that would make it interesting. Thank you. Yeah. Yeah, thank you. Come. This fell down so many times. I think it's okay now. Yeah. Either side will hear this.
Ahead and behind. Yeah, thank you. Hi, good afternoon, everyone. I'm so honored to be on this stage presenting on my topic of from cosmos to climate action. So I basically work with school students, especially middle school and primary school students, and I under the name Navi. Navi means Nalaya Vignani. In Tamil, it means future scientist. So my focus in conducting the workshops is nothing different from most of the speakers who have done the demo sessions and who spoke before me. Most of them has to be hands-on, and then it has to be have some fun element so that the students are engaged. And at the same time, how can we integrate the classroom curriculum concepts to classroom curriculum concepts so that they don't see astronomy as a totally different thing, but how there is an overlap, or they are complementary. And my teaching is also focusing on how can we improve the scientific inquiry-based thinking process among the school kids. So why space and sustainability? I think I don't have to emphasize a lot, because a lot of the speakers before me have helped me in answering that question. So like my journey in astronomy started with my other hobby, which is birding. So I used to go out and use my birding scope in the seashores and nature preserves, where you get the opportunity to view the birds, and at that time it's usually birding activity is much more pronounced during sunrise and sunset times, like Arvind Raja sir mentioned. So I get the opportunity to view the sunrise and sunset, and at different times of the year, how it basically changes, the position changes. And also because most of these like one who is interested in birding would go to places where there is less human activity, which means there is less light pollution. And I also got to enjoy the beauty of the Milky Way band with naked eyes. And when I saw like a bright object in the sky which I wanted to look at, I turned my birding scope towards the sky, and then there was this beautiful Jupiter, and that's how my journey in astronomy started. And while I wanted to start teaching about astronomy for the school students, I don't have a physics background, so I was actually looking for some kind of formal training, and that's when I actually approached IUCAA. And that is also because of my interest in sustainability. Like when I was conceived, I was looking for opportunities to reuse the materials available at my home to make toys instead of buying plastic toys out there in the market. And then I happened to listen to Arvind Gupta sir's talk on in TED Talk, and that led me to figure like where is he, and then that led me to IUCAA. And that's how my training at IUCAA happened. And I was among 35 35 teachers from Marathi medium, and I was the only one who doesn't know Marathi, and sitting for 2 days attending the training program. And during those 2 days, I actually got an opportunity to go around the campus also and listen and absorb a lot of things. And one thing that was very close to my heart was how when IUCAA was formed, Professor Narlikar made sure that the trees are not cut, but instead uprooted. All the banyan trees were uprooted, and then those were taken and planted, and the trees that you see here lasted for so long. So those are like sustainability practices that's built in, building this institution. And because I already had that inclination towards following sustainable practices, and I'm also a believer that the values that children carry are deeply rooted in what is taught to them during the formative years. So that those are the things that basically motivated me to basically find the connection between astronomy and sustainability. Everyone else, like I also start with teaching about the solar system, and also about the scale and the size of the planets and the distance of the planets using hands-on approach. Throughout my presentation, I'm not going to focus on the hands-on approach, but instead on how I'm drawing parallels. So when we talk about Earth and Venus, then we also students, most of the students know that they are like called twin planets, and they look similar in terms of size and Mars. Then natural question is like why is Venus not habitable while Earth is, and some of them will come up with the answer that oh it is very hot, and then the natural progression of question goes like oh why is it hot? So it has a lot of carbon dioxide in the atmosphere, and do we have carbon dioxide? So those kind of questions basically lead up to the positive feedback loop, discussions about the positive feedback loop. And I also teach online classes, so I try to take the FET simulations that exist out there to talk about the albedo effect, so those kind of things. And while teaching about where we are in terms of the cosmic calendar, and then telling them about how we actually arrived so late, but then we are impacting species that arrived before us. This is about the bird beak adaptation workshop that I did, where we used the everyday materials that we have at home to mimic how the birds would feed, and then what happens if those food goes, those environment and the food chain gets disrupted. So, and these species can evolve, the beaks can evolve, but not at the time scale in which we are basically making changes to the environment. So while talking about the lunar eclipse workshop, I also touched upon the lateral flight project, which was done by a Brazilian engineer, where the same concept of reflection and refraction is being used to light up homes, in slums in Philippines, where it is much more prone to cyclones. So, and there is a lot of interruptions to electricity. And while talking about sound lessons, there is also, these are inspirations from Ayuka. The one on the left is a wave model that I was trained upon here, and the right one I try to use, being local, whatever is available at home, like I'm trying to teach them on how sound travels differently through different medium. And this is where they are doing a role play of echolocation, which is used by a lot of marine animals, and the radar applications that we use, and the human-induced noise pollution, how do they impact animals, marine animals, and their ability to survive or find a mate or food. So in this is a role play exercise that we did in a school. And also touching upon the cultural heritage that we have, and how our events are closely interlinked to astronomy and also to nature. That basically gives them a deep sense of pride, not in by doing the right things, not for being superior, feeling superior, but to know that their ancestors did a lot of right things, and they also want to hold on to those values which are right. So the left one is the Pongal celebration, and the right one is the Chittirai, the Tamil New Year celebration. So both falls on the astronomical events, even though we may not celebrate them on the right day. I also get an opportunity first when instead of saying we are celebrating on a wrong day, if I say that we are our festivals are closely aligned, but then we are actually celebrating in a wrong way, wrong date, they are much more prone to accept that, rather than just pointing out that it's incorrect. So, and also showing the architectural significance of our Indian architecture, Indian subcontinent architecture, and showing that how basically celebrating nature is intertwined in our culture. While talking about the festivals, I also touch upon the Islamic calendar, and how Ramadan is celebrated during different months in different years because of because they follow lunar calendar. And I may be talking in knowing what I know, but I would like to learn more from people from different cultures to understand, and then propagate that knowledge to the kids that I work with. So this is a calendar that we created, and this is again a chance for us to talk about how the calendar system is different. I think Alok talked a lot about this in his yesterday's talk. So this is a platonic solid, so I also get a chance to talk about math through them. And then while talking about it, I also made them like conscious of when go and talk to your grandparents, when do they buy dresses, and what was the practices that they had at home during those days, and being conscious about the consumption at household level. So I also made them take pledges on what they can reduce. Some interesting things that came up were, oh, I have so many pencils, I just need two, so I will try to not buy more pencils, even if it is so small. I think the changes start from there. So this is Fibonacci series and drawing parallels across and hexagonal shape, and how tightly packing is also closely related in nature and our technology usage. This is again a bubble experiment and tessellation art that's made by kids. And finally, when I show this picture, they try to imagine how small we are in such a fragile system, while knowing that there is so many stars exist out there. So that basically keeps them going in terms of following the pledge that they have taken. I'm hoping I could interact more and looking for more learning from all of you. Thank you. Yeah, thanks.
Hello. Am I audible? Shall we? Okay. Good afternoon to the session chair, Dr. Shailaja, and many people from IUCA, ASI, and ladies and gentlemen. I'm from Jawaharlal Nehru Planetarium, Bengaluru, and I'm speaking as quickly as possible, challenges of communicating astronomy in the vernacular JNP experience. Especially, I'm going to share my experience as a science communicator for the past 45 years. Since my teens, I have been doing this. So this talk deliberates on various challenges faced by science communicators using vernacular, okay? Those who use vernacular, and especially I will take Kannada as an example. And it is quite a bit, it is the same for other vernacular languages in India. Of course, I'll share my experiences as a science communicator both in Kannada and English. This is a book on India's Mars orbiter mission, which I wrote in English, and of course I wrote in Kannada also. It is being updated now. And now, what is the context of this talk? Okay, the context of this talk is that the prominent publicity for the Jawaharlal Nehru Planetarium, Bengaluru, by the vernacular media, mostly it is vernacular social media, which is giving rise to the enhanced shortfall enhanced footfall, extremely sorry. And you can look at it, especially vernacular social media is giving a lots and lots of prominence for the organization, since we have many new programs, and because of that our footfall has reached almost 4 lakhs per year. Okay, and in addition to that, the reason why JNP has become much more prominent today is the availability of a new building with 2 auditoriums, 4 classrooms, and an activity hall, and many things which is under the smart city scheme. It has been provided by both, facilitated by both state and central government. So the state government wants to conduct many science programs here. And context, again, continuing with the context, there is a perception by the general public about the planetarium that where we can learn a lot about the heavenly bodies, whether it is sun, moon, stars, planets, whatnot, in fact even comets. And expectation of the vernacular public, what they feel is they can get information in the vernacular to a certain extent, by and large, on these impressive and conspicuous events at the planetarium. Okay, continuing with that, there is today lack of emphasis on many scientific on the part of many scientific institutions to communicate their capabilities in science, about science or their working vernacular languages. Lack of interest and awareness of many people who are in the domain of science to communicate in the vernacular, their own mother tongue. Not that all of them are like that, I'll say, because they have their compulsions. This is not a complaint, this is only an observation. And far more important is these are the challenges. Continuing with the challenges, lack of proper interface between the state education departments and academicians and researchers. See, textbooks have to be updated in the sense, lack of adequate representation of academicians in the textbook committees. I myself was there sometimes, and the way today what India has achieved in the domain of space, that is, there is no mention in any science textbook, at least in Karnataka I have not seen it prominently. We need not have to write paragraphs, but at the same time, at least conspicuously, succinctly, I have to inspire the students, and that is lacking. And continuing with the challenges, especially in JNP, what I have observed is, modest social and economic status of the visitors communicating only in the vernacular. Obviously, their exposure is also very limited, and lack of authentic vernacular sources. There is no authentic original information source for them in the vernacular. No, it is by and large copied from English, and bias towards sensationalization in the vernacular media, especially when it comes to eclipses and such things. More of sensationalization, less of science. I myself was caught in the middle many a times in TV programs, in fact. So this is very important. You can see here, a lot of school students from rural areas coming to planetarium, and under a program called Taralaya Pravasa, and they get many things at free of cost, and it's one of the immensely successful programs. And when it comes to translation also, the thing is not correct. Words are used. See, Kempu Chandragrahana, they say, Rakta Chandragrahana, these kind of things they use, it connotes something else. Okay, and there is no proper explanation. So these are all the challenges faced by planetarium staff and science communicators in particular, in fact, because too much of sensationalization by the vernacular media and too little of science. And so another thing is, editorial staff are there, they don't know what they have to give prominence for. Okay, for example, a lot of launches take place from India. That is the best way, that is a good opportunity to tell students, teachers about rockets and Newton's laws of motion. Physics can be taught very well by observing this flight of a rocket and a satellite. So that is why at JNP we have a program in which all the ISRO launches during the working hours, if they are there, we invite media and we invite students also and show them, and this is science in action. That is what we are going to emphasize. In fact, total lack of editorial control I mentioned, tackling the challenges, this is very important. Next 5 minutes, tackling the challenges only I will talk about. How do we tackle these challenges? So additional precautions are essential for science communicators, and compared to those communicating science in English, because the exposure of vernacular students is not that much, okay? That their social and economic status also plays a very important role. So what is essential in this regard? We have to use a very lucid language in the vernacular, okay? When we write posters, we have in JNP, we have a policy that the vernacular comes first, then English, by and large, that is the way. So, but use a lucid language which appeals to common man rather than, just a mere translation of the same. It doesn't, that will be boring. So this is the approach of JNP in general and mine in particular, usage of more conspicuous illustrations, videos and animations. In my book, you see, I have used Mars is telling all other planets are there in this cartoon compared to any other planet of the solar system. I am the nearest relative to Earth, it says, a cartoon says. So that goes into the mind of the student. Illustrations, animations and cartoons. And tackling the challenges, continuing, see, relating the discussed subject to day-to-day life experience. When we say that, to go to the moon, you have to achieve a velocity of, escape velocity of 11.2 kilometers per second. Who knows what it is, 11.2 kilometers per second? That is, in terms of miles and kilometers per hour, you say, that is 25,000 miles per hour or 40,000 kilometers per hour. What is the average speed with which we move on our roads? It is roughly average, I am telling, 25 to 30 kilometers in our roads with lot of potholes. So, but compared to that, 1,000 times that is essential within a short span of 15-16 minutes. This is what you have to appraise. Second thing is, when we talk about the heavenly bodies, the previous speaker spoke about Venus and Earth. See, so much. It is the evil twin. This is what? Earth and Venus are of the same size, but yet they are totally different. What is the reason for that? How big is Jupiter? How big is the Sun? How far is the Sun? 150 million kilometers, nobody will understand. 150 million and billion, we don't speak in India. Crores and lakhs are the ones which we use. Better to use that, okay? That is the kind of thing. And feedback is very important. We have to collect the feedback from the students, strongly appraising and prevailing them. Them means the people that who matter to understand the concept and language. You see, one thing we have to appraise, language is only the medium of communication. If I know English, it is not very great or anything like that. It is only a medium of communication. There was a time when we used to appreciate. Now there is nothing wrong. Okay, you have to appraise that. And finally, live commentary of vernacular on important scientific technological events of national and international importance like Chandrayaan-3. See, in Jawaharlal Nehru Planetarium, we had live commentary of Chandrayaan-3 landing in the South Polar region of the moon. I gave the commentary in English and Kannada thanks to the previous director who invited me to do that. See, there was a rage, I would say, in fact. Even the police constables used to come and thank me, sir, you told us in Kannada. So this is very important. This is very important. I commend and thank the previous director there. And recently, Shubhanshu Shukla came to us, and one of the wonderful events we had, students who could able to ask in the vernacular, they had the opportunity to interact with him. I translated that, the questions to English and answers to Kannada, this way, that way, and all those things. So all these go a long way. And the another thing which I have started is water rocket launches. See, this teaches the students more about laws of motion than anything else. For example, look at that. See, we have a very powerful launcher, at least 15 stories high. The rocket goes, but I am very cautious. I don't want to burst the bottle there. So one has to be very careful about it. And these are all these vernacular students. They are not English medium students. I apprise them, I explain them the laws of motion. For example, for our action, there is an equal and opposite reaction. F equals ma, Newton's second law of motion. Everything in Kannada I tell them, in fact. Communicating in English is different. That is part and parcel of our life. The challenge lies in the vernacular, communicating in the vernacular. And nowadays many more subjects are emerging, new subjects are coming up. So how we translate that? How we are going to inculcate uh, seriousness about those things to our vernacular communicating public? That is the most important challenge. And how we are going to tackle this problem. So the younger generation now, they have to take it up, and it is very essential for us to communicate science in the vernacular up to a particular point at least. You go to a small country like Serbia in Europe. Anybody has heard the name Serbia? It is part of Yugoslavia. I mean, former Yugoslavia. Slovenia you take, Croatia you take, Albania you take. They are all not even very small countries. They study by and large in their mother tongue. They have respect. That is what we need to develop. So the challenge is how effectively we communicate, not only as individuals, collectively. That is what is important. Thank you very much. I have much earlier itself I have finished. Okay. Yeah. Any question? If you have, yes, sir. Yes, sir. Yes, sir.
I just wanted to comment on one of the statements you had, that you feel that sometimes the vernacular media is biased and sensationalizes the news. I have actually had the opposite experience with it. In the last 1 year, I have been on various TV channels and also in the print media. I find that the Marathi print media as well as the TV media is very well informed. They take pains to make sure that the scientific content is correct and presented correctly. We also have the advantage that due to Narlikar's writings, many of the astronomy terms are already familiar to the public in Marathi. So they are able to understand. We don't have to use English words. We have nice translations of astronomical terms in Marathi. Whereas if you go to Hindi, Dev and I were on a Hindi lunar eclipse program, and that was the exact opposite experience. Although this was a national program, they were the ones who were trying to sensationalize it and trying to make it a fight between astrology and astronomy and so on.
Yeah. Yes, sir. I respect what you said. That's why I said I cannot speak for each and every language. By and large, I said I can take Kannada as an example. This is only an observation, not a criticism. Okay? This is an observation. Sensationalization means because, they feel that, the broadcast media feel that they need sensationalization. Okay? They have their compulsion to increase the viewership. I don't want to use the three-lettered words what they use, TRP or whatnot, in fact. But the things, they have their compulsions. We can't this one. But in Kannada, whatever I said, by and large, I myself have been part of it. Not everybody, but to a certain extent, many. Yeah. Yes, sir.
I agree with you that we need to communicate in the vernacular languages. We belong to an Urdu university where we are teaching sciences in Urdu medium.
Yeah.
So there's a lot of literature, not lots, but available at the school level and degree level. But at a higher level, we don't have much in Urdu. And we are making efforts to create serious translations or create new material. You have similar programs for Kannada too?
Yeah, Kannada. Yeah, we have programs, sir. Yes, it is very important. There was an attempt even earlier to translate my Kannada articles to Urdu by one gentleman. So like that, there are many people, enthusiastic people. The bottom line is this. So vernacular needs more emphasis. I'm not telling that English should. I'm communicating to you with you in English. I'm not against that. But let us give some importance to our heritage. That's what I am telling. Not too much. I am telling, let us not claim whatever we have not done. I am not of that type. But let us give importance to our heritage. Good. I hope you agree with me. This is my personal opinion. Kindly consider it as though it is coming from a independent science writer and not as any official or anything like that. So these opinions are my personal ones and only observations. Thank you very much.
Thank you so much. Mr. Guru sir, I now invite our next speaker, Mr. Kamal Kumar. so what Neeraj is pointing out is because we have parallel sessions and people are choosing to move back and forth between sessions, expecting us to follow a certain plan. And if we were to not honor that, we might deprive some people of listening to the talks they want to do.
So maybe you can take some that from the 7, 8 minutes, Kamal, if you don't mind, what I would suggest is very important, and it's always, we always say it's important, with a lot of good intention, but never really do much about it. And since people are here, maybe we can have, like, some question and answer, can we have some comments, open comments and discussion points about in terms of how you address all the challenges in communication. What are your comments vis-a-vis other people's work and our work? For a few minutes,
Take a mic.
no, that's it. I mean, so can we do that? If you're okay with that, we can do that for 5 minutes and then we can.
We have roughly 7 minutes before we
So
hit the
general
appointed
comments
time.
on the topic.
So we have had good enumeration of all the challenges we face when we are dealing with the communication in the vernacular. So I think what would be perhaps interesting is to listen from the audience about the solutions which they have found.
Okay, fine. So, good afternoon, everyone. Yeah, it was a very nice discussion in a way. It is more like inputs for my talk, and then also I'm giving something related to the discussion what has happened now. So, my name is Pawan Grampurohit. I'm from Indian Institute of Astrophysics. I basically do research on planetary atmosphere and ionosphere. Beside my research, I'm also interested in the outreach, science outreach. I do this science outreach communication and things like that. I write a lot of articles in Kannada and things like that. So, so this is a good forum, I thought, where I can present and then I can interact with the people. So, in that way, I'm thankful to the ASI symposium. So, to start with, I will go with this first picture, which says, this is a very famous quote from the Einstein. It says, you do not really understand something unless you can explain it to your mother or a grandmother. Okay. So what this is, I will again use this slide as my summary slide and then come back to after whatever I want to say that. Okay. So now what we are doing, so what I am doing here is that, as we know, because mathematics and science are often considered as a difficult subject to understand, it's not because they are written in English and they are also abstract in technical terms. That's what there was a very good discussion now. So how to bring out those terminologies, words, which can be, used for all the things. So it is very important to get those technical terms which can be used, and how to break this barrier and make science concept more accessible. So that if you are in a Maharashtra, if you are in a Karnataka, the moment if I say something, some words, it will be like, okay, so this is what the conceptually he wants to take. So what was our attempt? So importance of teaching in science in the regional language, which is very important, and I will tell you why. And then what approach I have started was writing stories and essay, which many of the talks you have heard, that they started building their local native stories and then started connecting to the science teaching. Translation of popular articles, there's a very good discussion just now happened, because when you translate something, it should not take some different meaning. So it's a very careful for any the science communicator, the translation becomes very important. Okay, and then art form like poem, songs, and skit. So I try to write a lot of these things. So I'll show it up those things. So there are some important quotes which I bought it, which is about Matrubhasha. The best science is done by people who have learned their mother tongue, and if you have to be creative, you have to think in your own language. You cannot be creative in a foreign language. So this is a famous quote by Rao. And then even Dr. APJ Abdul Kalam says that I studied in my mother tongue until I was in class 10th standard. I believe that we can have the medium of instruction in mother tongue even in colleges. Okay, mother tongue provides a close connectivity with the thinking of the young. So this again says that what is the importance of mother tongue are in a way of understanding science. So there was a recent UNESCO report which mentioned that research shows that education in mother tongue is a key factor for inclusion and quality learning, and it also improves learning outcomes and academic performance. This is crucial, especially in primary school, to avoid knowledge gaps and increase the speed of learning and comprehension. So that's the importance of Matrubhasha, or whatever the vernacular which we are thinking. Oh, there are followed many research also. If you want to go ahead, there is the field of science, specifically studying this learning a mother tongue, are called psycholinguistic, neurolinguistic, and cognitive science. So there are a lot of publications have come out, and they said that if you start when the kid's born, and then when you start talking to them, if you start with a L2 language, which is not your mother tongue language, and then their way of capacity building and their understanding, their memory things are completely different than when you start talking with your kids in your own language, mother tongue. Okay, so there are a lot of publications, there are many things, brain mechanism in early language acquisition. So there are all things have been done, and there are reports on this. So if you can see in the neurolinguistic, so it studies on relation between the brain and the language. So if you are learning more in your own language to start with, then you will acquire more and more understanding about any subject. Okay, so that there is a limbic system connections. So it's mostly because we are connected more with our emotions. If I want to say something, so there is a very famous story that there is a fellow came without, he was saying that I know every language, but you have to guess me which language I know. So it was Tenali Rama, this question was posed, and then what he did was he just poked with some nails to him, and then he said ayo, amma, something like that, which in his own language. So because our languages are more connected with the more emotions, right? So in that way we also learn certain things. So that's why the linguistic or vernacular, whatever the system which we want to start with, it's more important. Okay, so this is again psycholinguistic is also talks about why this language is important. And if you are talking about all languages, like how can we forget Professor NVG, JVN? So NVJ also I used because Dr. Nalikar showed us that science is not just for an elite, and by bringing complex astrophysics into simple Marathi stories, I think you all know that what is NVJ, right? So he proved that language should never be a barrier to the knowledge. He did not lower the standard of science, he simply widened the circle so that who can understand the science more. So this legacy, which has really given up for in Indians at least to use our vernacular language or our Matrubhasha as a medium of learning science. So we also have many experts who are wrote in Kannada, Professor L. Narasimhaya, Narayan Rao, Subbarayappa, and then Dr. B. Shailaja, she is here. So I grew up reading her books. I have a lot of collections. So that's how in Kannada literature, also we have a lot of science related stuffs which is coming up. So now, since the story built saying that yes, the mother tongue or the vernacular system of education is very much important. Now what I am doing, so I want to reach to the audience which are like a rural folks. Means they're with their languages. Like if you go to the Karnataka, it's a Kannada, Marathi in Maharashtra. So for them, I have to reach the science concepts, how I can do that. And then one is the students, where they are in the stages of learning and things like that. For them also I have to teach them. So how I can do that? I can do by drama and stories with the folk stories, language dialects. Has the very good discussion happened about dialects, current trends like dialogues from movies and social media so that they can remember something. Okay, and the approach, so this approach enables them, children, youth and elders, to engage with the scientific concept while enjoying the learning process. So when I use some cinematic dialogues, and then later I bring with some science concepts there, and then they will, oh, there was something in dialogue, and then they start understanding that. So that's how I actually kind of experimented with my writing skills, so which I'm showing up now. Oh, there is some problem happened. Okay, so I think there may be some issue with this PPT. So this was started with the articles writing. So I started writing articles in Kannada. Maybe this is the Kannada font. Maybe some issues happened. So this article was on recent 3i Atlas. So the articles has written in such a way that it will create a curiosity in the people. When they start reading, they think that. So the article write like that. There's a person has come from outside of the world and he has bought a lot of information. Do you want to see that? So the articles written in the Kannada dialects which they can understand. So then the way they approach us this reading, and then they'll start getting curiosity, oh, what is there in something? Then I'll slowly tune into the science concept, like, oh, what they are doing with this object now. Okay, so that is the one thing which in Kannada especially. And this is one more article which I wrote it during the COVID time. So I wanted to talk something about the solar wind effect on planetary atmosphere. So what I did was, because there was a corona time, and then we all know that when you sneeze, there are things, particles goes and hits and all that. So what I made was, so there's a earth, it has a magnetic field. Okay, and then I said like, it is wearing a mask. So the solar wind particles, as we know, it won't affect much because earth has a beautiful magnetic field. But if it is, look at the Mars doesn't have a magnetic field like how earth has. So it has lost that. So it will ask, earth asks like, Mars, wear a mask, solar storm is coming towards you. And then Mars says, oh no, I lost my mask. Maybe it's a funny, but the students start asking, oh, what is there, right? So when you write in those kind of articles or essay which provoke the students or start getting some curiosity in them. So, and then translation work, which is really a good discussion happened. So when we translate certain things, actually I'm thankful to Dr. B.S. Shailaja and Anantaramu. For this book, I translated Professor C. Vishweswaraya, another famous cosmologist. So his articles were published in the Baseline magazine, and then the translation work was given to me to translate things. Now here comes that important, whatever the discussion was happening. So when we translate these kind of things, we can't exactly translate like in the Google. Okay, you just take English and put it in a Google and it will translate to Kannada, Marathi and all that. But when we translate, we have to know the idea about like how this can connect it to the people. Now example, like if there is a statement like, so there is a roller coaster situation happens, something like that. The consequent its values has been taken into dizzy roller coaster idea. So this, if I just translate as a Kannada, it is Elu Bidu Ugi Bandi. So there is no meaning to that, right? So I have to choose some Kannada word or some kind of a phrases which people can understand easily. So then we say, how any ata, which is the snake ladder game, which goes up and down. Okay, so the translation also requires these kind of skills for any science communicator, which I started adopting. So I translated Professor C.V. Visveshwara and then S.N. Prasad articles, so which was like translated. Now I feel like I have made a justification for their articles, and then the readers has also taken very good way. So I think the second edition also it has come out. So it is very good response, and then I'm thankful to Dr. B. Shailaja, she is here. And then I started writing the kind of songs because when we want to communicate them, so in a rural folks, they cannot just listen this kind of stories or writing. So I wanted to do that. So what I did, I took some famous songs like this. So this is Kurdu Kanchana Kuniyutaliddu. There is one song. What it depicts is that it says that there's a powerful ghost, which is a Kanchana means the money, which is like going ahead and doing all sort of things. It's a very famous song, and then people do this, perform this in the schools and all that. Exactly for that tune, I wrote a song where I say that this is superstition or whatever that things which is started coming to us, and then unscientific things it's making to us, something like that. So in the Kannada, I started writing exactly for the same tune. I made this this. So then what happens is that when they have the tune and they have a song here, and then they will start singing. So that means they will also get to know that, okay, so what are unscientific things or those kind of things, right? So this is the way I started composing some songs for the science themes based thing, which was well taken also. And then, so I also write skits, the skits which is using the dialects which they can understand. So this is my handwriting. I wrote a lot of skits for this. And then, so this is about Andagnanada Solu, or Kurdu Gnana Solu means it's about this is a skit which is written for some rural people. They want to perform things. And then there's our IAA has a scope division, which is beautifully doing these kind of exercises, and they given me the opportunity, and then I wrote this. And then even kids in the rural side, they are performing this. So you can see that Kurdu Kanchana is like this. That girl, the Kurdu Kanchana means they only thought all that, and then they wear the mask and all that, and then they started dancing that I am like this, I do these kind of things and all that. Okay, so yeah, so they are singing that song which I wrote it, and then she's performing, and then people are observing this. Okay, and there is also one more skit we performed in our own institute where I used the cinematic dialogues and all that, so that the audience, so depending on the audience, what kind of audience we are looking, so based on that our writing has to be changed, or the words we wanted to bring it out. So this was also done. It was very well accepted, well taken, and then people were appreciating that. Okay, so so again, as I said that I again want to come back to this slide. So it says that unless you can explain to your mother or grandmother, see, what that needs is that actually a good knowledge in your mother tongue. So if I want to tell to my mother that, look, I'm doing research on planetary atmosphere and ionosphere, I cannot bring her that there is photonization happening, there is an electron is exiting, right? So I have to explain her with some basic thing. That requires vernacular education. And I'm also sure that 80% of audience here are done their schoolings maybe in their own mother tongue language, right? So because of that, you are, almost have reached to this stage where we are communicating in science in the English or other languages. So that's what my point is. So I want to thank, because again, my school, because they started teaching me in Kannada, I also learned in Kannada medium from there. And then my teachers, like Shailaja ma'am here and most of them, planetarium where I worked, and then many colleges, and then scope section from IAA, and everyone. Thank you, and if you have any questions. No, the concept like Oogie Bandi and all that we don't want to use, because that concept like Oogie Bandi, it won't sit to that. Again, the context we have to see. Whenever you are writing article, it's not about just a thing, it's about a paragraph, what we want to convey the next sentence and the previous sentence. Based on that, we have to use this. So I'm just saying in a vague way that I cannot use that Elu Bilina Oogie Bandi, Mele Haro Oogie Bandi, that. Instead of that, I used as how any ata, because, yeah. No, it's not about Elu Bilu also. No, okay, I got it, but.
So maybe that's a discussion to be had later.
Yes.
Last question, if we have. And if not,
Okay.
then let's
Thank you. Thank you.
once again. I invite our next speakers on the stage. In our schedule, it says later. It will in fact be, you get another speaker for the same talk. It's called. So we can start off with
Good afternoon. Thank you. Am I audible? So, all right. So, thank you so much. So, we are part of a non-profit organization called Bangalore Astronomical Society. So, he is Nath and myself. My name is Pramod. So, basically, we are a group of volunteers with common and collective interests. So, the idea was to get with common interest people, take it to the rural people, and explore the basic astronomical concepts and get it to the places where it was unable to reach or it couldn't reach. So that was a common and a collective interest from our side, a small effort which we could do. So basically what happened was here, we as a part of community, we are all a group of collective people with only one common interest, which is astronomy, and how do we simplify it to take it to the public. So that was our motto. So basically what we do is we started doing it on our own. So in terms of, since from 2005, so a group of, a collection of people, unorganized, or the people with common interest coming together, sharing their own knowledge with the group and expanding it to become few of the volunteers and get into certain places where we could reach out and pass on this information. So in all these years, what we have seen is the interest level which has been grown in the common public. So the interest level which within ourselves, I mean, there are a couple of graduates, there are a couple of PhD holders within the group. So we have come across all these stages. Now with this, we, when we go to public, so we wanted to have a formal structured approach. So we also devised few of the workshops for college people. We also organize few other stargazing sessions, and the Snehit will take over. So we also have few of the hands-on activities where people can take their experiences with them once after these activities are conducted. So for example, if I have to put it across, so if we are conducting an activity like, painting on astro painting. So for example, what is the experience they are going to take? So they have their own imagination which has been put on the paper, and the experience they are going to carry it afterwards. Anything, the activity which is done on the particular location during the event, that experience they are going to carry it themselves. So there are certain things which are simpler to make, the activities which are simpler to conduct, and it gives an enormous amount of knowledge, and also it also gives a way to expand their knowledge. For example, if they carry it, the next time they are going to ask their teachers or the others in terms of what is that the kind of activity what they did, and what is the extension of it. So that is what we always wanted to inculcate in them. So with that, so what we did was, so we wanted to have them, their experience enhanced. So we also have a collection of telescopes which we got it in terms of out of all these years. So we have a dedicated solar telescope where we can watch, I mean, in terms of there are 4 to 5 things which we can watch with the use of that solar telescope. So that is one. So, and we also tell them what is the importance of using this and what are the things they could see using that. So that is one, that is a recent procured one. We have an 8-inch telescope which can be used by the public. So we take it to an activity, so wherever we go, so we carry it along. We also have a Schmidt-Cassegrain telescope, and the one which is of a 16-inch telescope, which is always operated by us, since we all know we all are trained on how to operate telescopes. So we ensure we show them the wonders of the night sky. So in wherever the part we go, so most of the times our volunteers are searching for new places. So in one of our recent ventures, I mean, in terms of recent one, so we got into a place which was remotely located, which is almost 40 kilometers inside, I mean, outside the existing location. So now the things which we did in all those locations, I would want the SNEET to showcase it to you, so that you know what are the things which has happened during that time.
Can you guys hear me? Okay. So basically what our topic is, we wanted to reach out to rural kids. That is our main focus. So one of the questions that the audience came up with in the morning was to bring the students to IUCAA, bring at least hundreds of students to IUCAA. But that might be not logical every time we do it. So one of the things that Bangalore Astronomical Society is focused on is to reach to the rural students who don't have access to telescope or astronomy. As a part of this, there are 2 scenarios that we have done. So there are 2 government schools that we have reached out. We went for a recce to understand if the skies are dark enough, if we can do the outreach. As a part of this recce, we identified there are 2 schools within Karnataka where we can reach out. And we have gone there and we have bought these telescopes over there, and we have taught them what astronomy is and how to see through telescopes. And this is the experience that we had, and that's what we wanted to discuss about. So here I go about it. So we've done with introduction. So this is the first project that we were working on. This is called Project Hadgar. This is the Hadgar Government School. The Google map is just to showcase how far is it from a local community or a local city. This is almost about 40-45 kilometers away. So the students don't even have basic amenities like hospital or anything, but there is a government school running, about 200 students from grade 1 to 7. So whatever I'm discussing now is basically everything happened over there in the local language, happened in Kannada. So we go there, we talk to them in Kannada, that's when we start connecting with them. So if you start with something else, and we also tell the teachers not to go with this school per se, or make them stand in a straight line, sit there, you're going to have lecture. No, that's not what we want to do there. We tell the children to do what they want. Then we set up our scopes. We tell them to see through this solar scope initially, so they'll understand, okay, what is the sun? What are the parts of the sun? What wavelength they are looking at? Basic things. We don't want to go into detail where they'll get confused of what's happening over there. They have seen the sun normally. We are using the solar scope. We teach them what's happening there. Then comes the important part which has actually worked for us. This is probably something that everybody wants to take, and if there are any more feedbacks that you guys want to give us, we can take it. The activities that we do is what has connected with us. So it might be simple activities, what we are doing. There'll be a little bit of more explanation about the activities that we have done that's worked for us. And then once the activities part is completed, then we use our scopes to show them what is there in the night sky. One of the things that the kids always ask is when they are standing in the line and looking at the scope is, the first thing their curiosity, to build that curiosity, they'll ask is, how much is the scope? So we all know how much we have spent on our scopes irrespective XYZ area. And the moment you tell them some amount, the kids are like, so you spent so much amount to just see a dot. So basically what you're seeing is just a dot through the telescope. It is nothing much. But the more detailed we go in, probably we use more eyepieces, we are using some other aspects, we get that. Then they'll start thinking, okay, in the Saturn, they can see the rings, okay? Then in the Jupiter, they can see the bands. These are the things that they will remember. We don't need to go into detail, but what we want to do is spark that curiosity within them to say, okay, this is something that I have done differently, apart from my school days, which is nothing but sit in the class, do the curriculum, and come out of it. So the goal is to make them understand there are some things beyond classroom, and that's what we are trying to do. This is basically what we've all discussed from the morning. So some of the aspects that has worked for us. Our ultimate goal is for the children to understand that we are trying to teach them something new. So the Hudgar School was really a learning curve for both of us. The moment we reached the teachers and the decision makers over there and we planned telling that, okay, this is what we do, the teachers were really excited. Most of the teachers have not even used the telescope. So that was a big advantage for us. So we just wanted to tell them, okay, we will showcase to you what is going to happen in the night sky, how it looks. We went there. We are all volunteers, so we picked up our cars, picked up our scopes, we carpooled, we went there, we set up everything like everybody said. So what we did was everything is in Kannada. So what I'm trying to explain is more probably in English, but over there, whatever we communicated was in Kannada and really worked out for us because we were able to connect with the teachers, the students, and the parents as well. Because even for parents to send them somewhere telling that, okay, these are new guys, it's not easy. We need to take that responsibility, but that really worked out for us and we had a really nice experience. Once we started showing them, they were really eager to see more objects. We couldn't extend past 10 p.m. because they needed to go back homes, and the only way to reach back to their homes is by walk. Most of them even didn't have vehicles. So whatever was organized was really good, and what is the best feedback which we got from one of the kids was she was continuously asking questions. So whatever it might be, could be physics, could be things, that really helped us motivate to understand, okay, we can spark that curiosity. The moment we have sparked that curiosity, we have done our work. That's exactly what we were looking for. And most of the children who were just walking around, enjoying the day, trying to understand what's happening, how is the sky, how the Jupiter looks through the telescopes, that really worked out for us. This is exactly what we have done, and that's what's the context about. The second engagement is about Kotigere. This is something that we have done from the past 15 years. It's the same methodology. We go there, we set up our scopes, we start with Scholar scopes, then comes the activities, then the observation sessions, and then the kids depart. But what has happened in 15 years, you might ask, okay, what we've done? But since we have started, there were only about 7 kids who would have started initially. But later on, as of January 2026, we have more than 300 students coming for this activity. It's not just that particular school which has come. There are other schools who have joined. Word by word, they would have understood that, okay, someone is trying to do something different over there, and we have come there and we have done the same thing, activities. And this school especially is very close to us because we have been partnered with them for more than 15 years. And we have multiple students who have surpassed just saying that I don't want to take science. They have taken science, they have gone into mainstream, some of them have finished their PhDs. One of the students is now doing PhD in Rice University. They're all there. So this is something that we wanted to discuss as well. So what worked for us was basically the activities. So some of the 3 or 4 activities what really worked because they'll keep the kids engaged. They really want to do it. Then they'll understand what that activity is about and what they learned it about. So I would just request Pramod to take over and explain about these activities.
Thank you. So whenever we plan our activities, so for example, when we go to either Kotigere or the Hudgar school, so these are the things what we actually plan. So based on the interest, instead of keeping people occupied only with the theory sessions, so we would want them to have hands-on experiences and have fun across and also learn at the same time. So one of the activities, so I wanted to give you an example where, so this is one of the latest photographs from the Kotigare site. So this is from Hudgar. This is also from Hudgar. So what has inspired from our visit, or the one which we have conducted, the activities, what they have come up with. So that is the one. So here on the left far picture, if you could see, so that is the one where people are actually having this individually printed sheets. I understand what would be the next effect. So here we have printed a icosahedron. So for example, to have that particular the 3D effect for them to learn. So we wanted to have them cut across, paste that with carefulness. So we wanted them to paste it and experience on the features of the individual planets, because everyone were given those handouts, so which we had printed. So, and they would cut, they would see the features, they would learn about those objects, and they would exchange the knowledge with others. So that was the first activity, so which was conducted in the day hours. So this was followed by the sun. So solar viewing activity explaining about the sun, and followed by the interaction with the students, interaction. So we were open to questions all the time. So those were the activities. And so here is what the extended picture of that. So here is one of the testimonial from the teacher after finishing one of the sessions. So she was really enjoying about what was done through. So here we are here, so we wanted to have that impact, the creativeness to come out of those students. So that was our motto, and the inspiration from the long-term partnership. So that was the one. So we would want to recce more places. We would want to get into much more rural places into it, and get this expanded with the help of that volunteer support what we have, and also with few of the things, collaborations what we are looking forward to. Any suggestions in terms of activities which are hands-on or anything? So all are welcome. So we would look forward to getting it expanded on that. Thank you.